Yeah, hello. Also from my side, my name is Wurster. I'm from the University of Stuttgart as well. And today I'm going to present our joint work together with Jacopo Soldani from the University of Pisa about the essential deployment Metamodel, where we did a systematic review of deployment automation technologies. And based on our review framework or research design, we selected 13 heavily used deployment technology, heavily used in the industry, in order to review and analyze. And as you see, we chose a lot of prominent and also hyped solutions like Puppet, Chef, Ansible, and Kubernetes, for example. And what they, or where we actually focused on, were on declarative or automation deployment technologies. And with declarative, this means that you can give them, or you can define your desired state you want to reach, and the underlying automation technology is deriving the necessary steps to transform your application into your defined state. And all these technology, they focus on automation, of course, but they differ in a way that you are able to express your deployment model or your application or your desired state of the application. And this leads to a couple of challenges. It's on the one hand, it's rather difficult to compare these technologies by their modeling capabilities. It's also challenging to choose a specific technology up front when you start to develop an application, because applications are under constant change, and this could lead to some migration effort. And if you are locked into a certain technology, this can lead to certain effort in order to, for example, to change the cloud provider you have chosen, or even the complete technology or the deployment automation technology you have chosen. And also this impedes deployment automation research in a sense. For example, if researchers base their research onto a specific technology, they cannot easily prove that some method or some new concept also applies to other technologies. And that's why we did a systematic analysis of the selected technology in order to distill the essential parts of that declarative deployment technology in order to derive the essential deployment Metamodel. And what we discovered, and what's also one major contribution of our paper, that we have seen that these technologies, they fall under certain they can be categorized, so to say. So on the one hand, and this is also the biggest group, we have the general purpose technology, that all of them support a certain set of features that we have defined in our paper. And for example, of course, as they are declarative technologies, you can specify your desired state you wanna reach with your application deployment. You can split or structure your deployment into logical parts. It is also supported to create custom, fine-grained and reusable entities. It is possible to hook or influence the deployment lifecycle, and they also support the multiple cloud providers and cloud platforms, and of course they target different kinds of cloud offerings. As a second group, we have to provide specific technologies. And the provided specific technologies, of course, they are restricted to a single cloud provider. So, for example, with Microsoft Azure and AWS, the cloud formation. So for them, it just only makes sense to support their own platform. So that's why they are there. And yeah, last but not least, there are the platform-specific groups with Docker, Swarm, and Kubernetes and CF Engine. And they are restricted in a way that they only support a certain cloud delivery model. So for example, with Kubernetes and Docker, of course, you only can deploy containers, and with CF Engine, for example, they assume an already running infrastructure. So you can only work on top of an IaaS layer. As a second contribution, or as the result of the analysis, we came up with we found the essential deployment Metamodel. And our Metamodel, on the one hand, there consists of components. For example, a component, could be an Apache web server, and this Apache web server, there could be a relation to another component, for example, an Ubuntu virtual machine, and as they are typed, components and relations are of a certain type, and on top of that, components and also relations, they can express properties. This is of course very important in order to define the desired state we want to reach with our deployment, and as well you can, in order to influence or look into the deployment lifecycle, an application developer needs to be able to define certain operations, for example, how specifically to install this Apache web server. And operations and components you may use artifacts in order to be implemented. So for example, these operations I just mentioned, this could be delivered with a certain file, and as well an artifact also implements a component in a way that there is some kind of artifact bundle that represents this Apache web server. And to make a short example how this will look like in real life, and also because we have not that much time, I can only show one example, and this is an excerpt from a Terraform deployment model, where on the one hand we can define a resource which has a name, and this defines basically a component we want to manage or we want to deploy. So we have the order app VM, and this component is of a certain type. In this case, it's an AWS instance. We define a certain set of properties. So, for example, which Amazon machine image will be used, the key name, and the instance type, and stuff like that. And of course, we can express some relations to other components inside the model. And on top of that, there can be operations that are executed during the life cycle of the deployment in order to do something special. In this case, we have a simple statement in order to add an additional user after the virtual machine has been created. To conclude our this talk, we showed or we introduced the essential deployment Metamodel, and the Metamodel helps or provides a basis for a common understanding of the declarative deployment model. It supports the decision making when you have to select a certain technology. It also eases the migration, the processes between technologies, and it provides a basis for deployment automation researchers to evaluate their concepts. And as future work, we envision the EDMM as a basis for technology agnostic modeling, and also to enable some sort of transformation based on the essential deployment data model, and a transformation to be specific into a certain kind of technology. Yeah, thanks for your attention, and I'm happy to answer any question in the poster session or right now.
Thank you. Questions? Oh, there will be the poster session, so I think we send all 5 presenters. Again, because everybody was